everyone, this is Melanie Fainall here to talk about my STEM curriculum lesson for Module 3. So I found our lesson for this module from the National Science Digital Library, and the lesson is called Build an Anemometer. For those of you who are not familiar with what an anemometer is, it is a weather tool that measures wind speed. And so it has the students create this anemometer using 4 small paper cups, a push pin, sharpened pencil, 2 strips of cardboard, and modeling clay. And the goal of building this anemometer is to use it to test the airspeed at different spots on the playground. And then the reason why they're testing the different airspeeds around the playground is because the goal would be to put a wind turbine on the school playground so that we can have a cleaner energy source right on our school's campus. So the first step was to build the anemometer. So right there I have the anemometer that I described in the earlier slide. The only thing I didn't talk about was you do need to color one cup a different color just so that when students see it spinning around they know when it comes back around. So then I measured the wind speed on the playground. I measured in 4 places: the garden, which was in the last picture, a gate by our school parking lot, in the middle of the playground, and then near one of our kickball fields. And how they measured it is you'd give students a timer. They would time the anemometer for 1 minute and count how many times it makes a full rotation. Unfortunately, it was not very windy when I tried this, so most of them got a 0 for how many times they spun around, so this project you might have to do over a couple of days. As they are counting, they're also analyzing and collecting data, so I used my Numbers app on my iPad to create a spreadsheet and document how many rotations each anemometer did for each trial. And then I also created a map of the school playground where eventually, once we got all the data, I could plug in the average or how many spins they did in each of those spots to make a comparison about where the best place to put the wind turbine would be. At first I thought this would be definitely a transdisciplinary lesson because in the lesson they do a nice job describing what's an engineer, why do we need to use wind power to help us build something, and then even describing what is a wind turbine and why is it important. But as I was actually doing the lesson, it's more interdisciplinary just because it lacks that engineering design component. So it describes about a real-world connection, but it really doesn't have students involved in the engineering design process. So most of it, again, was interdisciplinary because you have those math and science connections going together and a little bit of engineering as well. Where I saw it kind of creeping into the transdisciplinary side was definitely with the real-world connection. That there are people out there measuring wind speed and building these turbines so that we can create cleaner energy. And then I created the curriculum plan diagram. So the main goal would be talking about anemometers, and then with the science it's looking at the weather tools, how can we measure wind speed, and then with math it kind of deals with the time and number sense, so being able to read a clock. Also being able to read and compare numbers, because eventually they're going to have to compare which number is bigger, which one's less, where should we put the wind turbine, where shouldn't we, based off those numbers. And with those that big goal, the question about what spot on the playground gets the most wind. There's also, again, a little bit of the engineering component to it with the real-world connection, but it wasn't as prominent as these 2 areas and skills. Thank you for listening. Looking forward to hearing your comments.